SIGVIEW can stream signal and analysis data live over a network, from one running instance directly into one or more other instances. This is useful when you want to monitor a signal acquisition remotely, share a live analysis result with a colleague, or simply bridge data between two separate SIGVIEW workspaces on different machines. The setup is simple. One instance acts as the sender, here on the left. It attaches to any signal window and broadcasts its content over TCP. The other instances, here on the right, act as receivers. Each receiver connects to the sender and displays the incoming data as a normal signal window, with full access to all the usual analysis tools. One sender can serve multiple receivers at the same time. All of them receive identical data. Let's see how this works in practice. I have two SIGVIEW instances open here, the sender on the left and the receiver on the right. For presentation purposes, I have two instances running on the same computer. In a realistic use case, those instances would run on separate computers. On the left instance, I start a simple data acquisition from the sound card. Now I'll add the network sender tool and attach it to my data acquisition window. To do this, I go to the Custom Tools toolbar button and I select Network Sender Tool. SIGVIEW creates a new window and immediately starts listening for incoming connections on the default port 9770. You can see the status text in the sender window. It shows the block rate, the frame size, and how many clients are currently connected. Right now, nobody has connected yet. Let's switch now to the right instance and add a receiver. Again, we go to a Custom Tool menu and select Network Receiver. Since we are on the same machine, the default host address of localhost 127.0.0.1 already points to the sender and the port matches. The receiver connects immediately. Back on the left, the client count goes up to 1. And here on the right, the live signal appears. Every update on the left is now reflected instantly on the right. Through automatic axis scaling on the right, the signal looks slightly different. Now let me show the same thing with the spectrum instead of recorded signal. I'll open an FFT window on the left side and attach the sender to it. Again, I open Custom Tools menu and I select Network Sender window, now attached to the FFT window. To show you how it's done, I will now change the port used for streaming of the FFT in the corresponding Julia script. As you can see, I can change here the default port from 9770 to 9771. I simply save the script and it is applied immediately. As you can see here, now I'm streaming on the port 9771. On the right, I open a new network receiver, again by selecting it in Custom Tools menu, Network Receiver. And as you can see, it cannot connect because it tries to connect on the port 9770 and we are expecting connection on the port 9771. Let's edit the script on this side. And here I can change the port from 9770 to 9771. If you would stream between different computers, this is the place where you would also enter the correct IP address. Let's save the script on this side. It is applied immediately. And as you can see, the spectrum is streamed from the left to the right, and we see the spectrum on the right the same as on the left. And here I can also use any of available SIGVIEW tools. For example, I can use the maximum instrument to see the maximum position in this spectrum. The sender window keeps track of everything: block rate, total frames sent, and per client statistics, including how much data has been transferred and whether any frames were dropped. So that's all there is to it. 2 tools, a port number, and an IP address. Thank you for watching.